All right, so here we have x e to the negative 0.5x, and we're going to do the same thing we've been doing. So first things first, let's get our pen out here. Let's put her back to purple so we can write that way, and then we'll draw in the other colors. So what is our domain? Well, basically any number we put in here should work. So it looks like from negative infinity to infinity is going to be our domain. All right. So if we set our this equal to 0, we're going to get an x-intercept at 0. So that's going to be our x-intercept. And if we plug in f of 0, what do we get? Well, we're going to get 0. So that's going to be our y-intercept. Okay, so that's going to be at 0, 0. Okay. Now horizontal asymptotes, vertical asymptotes. Well, horizontal asymptote, because of the way this works, we're going to get a horizontal asymptote at y equals 0. Okay, so it's going to be, if we think about how the E works, it's going to give us a horizontal asymptote at 0. And there's really not much else we can get in that part 1. So let's go to part 2, our derivative, first derivative. All right, so this is going to be a product rule. And so what we'll do is we'll take our product and we'll say, okay, well, let's take our first times the derivative of the second. So it's going to be e to the minus 0.5x. And then times, now the derivative of the inside part, so that's a negative 0.5. So we'll put a negative 0.5. And then plus, and then now we have e to the negative 0.5x times the derivative of the first, which is just going to be 1. Now that's going to simplify to what? Well, that's going to be a negative 0.5x e to the negative 0.5. That's a 5, not a 0. 5x. Okay. And then this is just e to the negative 0.5x. Now, for simplicity, I think what we could do is we could take out e to the negative 0.5, not 0.5x, and we have what's left over? Negative 0.5x plus 1. Okay. All right, so that's going to help us figure out partition numbers. And so that's going to be, it looks like if we take 1 to the other side and divide by a negative hat, that's going to give us x equals 2 as a partition number. And it's also going to be a critical number because if it's not anything it cannot equal, because it can be equal to that and it would still be fine. And so if we do that, let's do our 2, maybe a 3, and I don't know, 0 is probably the easiest. Okay. So again, this is the first derivative. So if we plug that in here as 0, that's going to be a 1, and that's going to be a 1. That's going to be positive, and so that's going to be plus. Now, if we plug in a 3, that's going to be a negative 1.5. That's going to make that a negative, and that's going to be, so it's going to be a negative over here. Okay. So if we're going up and then going down, that means that here to here, this has to be a local maxima. Okay. So on this side, it's increasing. This side, we're decreasing. And so if we write all that out, we'll say, it's increasing from what? Negative infinity up until 2 and decreasing from what? 2 to positive infinity. Okay. And we said there was a local maxima. So the maxima, and it was local because we don't know if it's absolute. That's going to be at 2 comma what? Okay, well, if we plug in 2 into our equation, we're going to get, looks like 0.736. And again, way more than I can actually draw on the graph, but that's what we'll put in there. So that's what we'd have. Okay, now part 3, second derivative. All right, so let's go back to let's use this piece here, I think is what we're going to do. So we'll have a product rule here, and then we'll just have this piece here. So if the product rule, that's going to give us a negative 0.5x, and then we'll have e to negative 0.5x, and then times the negative 0.5, and then plus, and then what do we have? We have e to the negative 0.5x times, and then a derivative of, okay, so that goes, okay. And derivative of this piece is going to be a negative 0.5 plus, and now we have the derivative of this, so that's going to be, well, we know because that's going to be the same as that, we're just going to have a negative 0.5, and then we'll have a negative 0.5 times e to the negative 0.5x. All right. So let's see here. We have a 0.5 times a 0.5, so it's going to be 0.25. It's going to be negative times negative is positive, so 0.25x e to the negative 0.5x. Okay. And then we have what? A negative 0.5 times this and a negative 0.5 times the same thing. So two negative 0.5s adds up to a negative 1 e to the negative 0.5x. Let's do the same thing we did last time. Let's pull out the e to the negative 0.5x, and we have what's left over is a 0.25x, and then minus 1. Now, that's not a negative here. That's a 0.25. All right, so now if we take 1 over, that's going to be 1 multiplied by 4. So it looks like x is equal to 4 is a partition number and a critical number. Okay, because it can equal that. So if we do that, let's draw our thing here. We have a 4. Let's go one higher, and let's go to 0 because that's the easy one. So this is double prime. We plug in 0 here. That's going to give us a negative and times that. So that's going to give us negative, and we need to put our 0 here. So it's going to be negatives over here. Put a 5 in here. That's going to be positive, big positive, subtract a little. And so that's going to be positives on this side. Okay. All right. So this one, again, because it's a second derivative, that's an inflection point. And we're concave down at this point and concave up at this point. So if we write that, we're concave down from negative infinity to 4 and concave up from 4 to positive infinity. And our inflection point is going to be what? 4 common. We plug in a 4 there. That's going to be 4. And that's going to be, we have to plug it in and figure out what that's going to be. All right, so it looks like to be a 0.541. So where's my thing? 0.541. All right. I think that's everything we need. So let's draw. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. Hopefully we won't need anything further than that. So horizontal asymptote at y equals 0. So that means something like that. Anything else we know? Nothing in red. So now let's start drawing our blue. All right, so 0, 0 is going to be a point. What else do we know? We know, where's that other one? 2.736, so 2 up a little bit higher. And we also know what 4.541. So 1, 2, 3, 4.5. So it's going to be down below there somewhere, maybe about that. And we know that this is going to be our max. And so it's concave down from negative infinity to 4. So basically, it looks like what we're going to have is we're going to be kind of coming up. And again, if we don't worry about what it is, we'll be coming up to there. So that's 4. And now we're going to be concave up. And so here we have a point of inflection. So it's going to have that line. And so now it's going to do something like that. And again, drawing this, it's going to kind of come down and then it's going to kind of do that. It's not good there, but that's kind of what it would kind of be blown up for. You have this point of inflection, something like that. Okay. All right, so that's how that one would be. Hopefully that helps, and we'll come back with another one.